Okay, let us start this worksheet on quadratic equations. The first question in this worksheet is if 2 plus iota root 3 is a root of the equation where p and q are real. See, this is very important that this is mentioned in the question, because when it is mentioned, it means that the coefficients of this quadratic equation are real. That means if one of the roots is imaginary, which is 2 plus iota root 3, then another root will be conjugate of this root, that will be 2 minus iota root 3. So just by looking at this root and this condition here, we can say that the other root is 2 minus iota root 3. And now you just need to find value of p and q. What is p? P is sum of roots with negative sign. What is sum of roots? It is minus coefficient of x divided by coefficient of x square. So in this case, sum of roots is equal to negative p, right? So what is sum of roots? I'll have to add this and this one, which is 4, which is 4. Hence I can say p is equal to negative 4. And now look at this q. Q is product of roots. Product of roots is what? Constant term divided by coefficient of x square, which is 1. So q is product of roots, and if I multiply 2 plus iota root 3 and 2 minus iota root 3, I will get 4 plus 2 squared plus root 3 squared, that is 3, right? And it is equal to 7. So the product of roots is 7. What is the product of 2 plus iota root 3 and 2 minus iota root 3? You can say that it is 2 squared minus iota root 3 squared, right? What is 2 squared? It is 4. What is iota square? It is minus 1. So minus of minus will become plus. Root 3 squared is 3. So 4 plus 3 is 7, right? So q is 7, p is negative 4. What is the right option? Option A. Okay, let us move to the second question here. Alpha and beta are the roots of this quadratic equation. That means alpha plus beta is equal to minus 2b by a. Alpha into beta is equal to c by a, right? And I need to find value of this expression, which is nothing but, if I take, let us say, LCM, square root of alpha beta here, then in the numerator I'll have alpha plus beta. What I mean to say is this expression can be written as this expression. Okay, so alpha plus beta I already know is minus 2b by a. Alpha into beta I know that is equal to c by a, so square root c by a. Now what you can do is, this root a is nothing but root a into root a, right? So one of these will get cancelled and this will come here. So the answer option will be minus 2b by root ac, which is option C. Okay, let's see the next one. If alpha beta be the roots of this quadratic equation, then the value of 2 alpha minus 35 cubed into 2 beta minus 35 cubed. Look at this equation. I've got 35 as a coefficient of x, right? Minus 35, right? And 2 as coefficient of x square, and alpha beta are the roots of this quadratic. So what I can say, that 2 alpha square minus 35 alpha plus 2 is equal to 0, right? Now see, if I take alpha common from this expression here, then I can write 2 alpha minus 35 inside plus 2 is equal to 0, and this will mean that 2 alpha minus 35 is nothing but minus 2 by alpha. 2 alpha minus 35 is nothing but minus 2 by alpha. Similarly, I can talk about beta. The expression here and here, these two expressions are same, right? So I can say the same thing about beta also. Otherwise, what you can do is you can simply replace x with beta and say 2 beta square minus 35 beta plus 2 equal to 0. Then you take beta as common, and then similar expression will come for beta also. 2 beta minus 35 is equal to minus 2 upon beta. Okay, now you just need to find value of product of their cubes. Okay, so this here inside this bracket I can be replaced by minus 2 by alpha cubed minus 2 by beta cubed. Okay, so the value will be minus 2 cubed is minus 8, minus 2 cubed again minus 8, minus 8 into minus 8 is 64, and in the denominator you will have alpha beta cubed. And what is alpha beta in this case? Alpha beta is product of roots, because alpha beta are roots of this quadratic equation. And what is product of roots? Constant term divided by coefficient of x square, that is 1. So the denominator become 1, and the answer for this question is 64, that is option B. Alright, so let's move to the next question, which is, this is a similar question that we did in previous worksheet. So alpha and alpha square be the roots of this expression. I told you that once you see this expression, you should be able to manipulate it like this. X cube minus 1 is nothing but x minus 1 into x square plus x plus 1 equals 0. So if alpha is one of the roots, then I can say alpha cube minus 1, because if alpha is one of the roots, then this expression will become alpha square plus alpha plus 1 is equal to 0, right? Alpha is a root of this quadratic, so it will satisfy it. And if it satisfies it, then I can put alpha here also, because this expression will also be equal to 0 when x equal to alpha, right? So I can say alpha cube is equal to alpha cube minus 1 is equal to 0, hence alpha cubed is equal to 1. And if alpha cubed is equal to 1, then I can say that alpha raised to power 31 is nothing but alpha raised to power 30 into alpha raised to power 30 is 1. Why? Because alpha cube is 1, so I can raise it to 10th power, it will still remain 1. So alpha raised to power 31 is nothing but alpha raised to power 62 is nothing but alpha square. You do this yourself. Alpha raised to power 60 into alpha square, alpha raised to power 60 is anyways 1, so this is nothing but alpha square. So the roots, these roots are nothing but alpha and alpha square, and I need to find the equation whose roots are alpha and alpha square. See, what is sum of roots alpha and alpha square? You can obtain it from this equation. You take this on the right hand side, so alpha square plus alpha is nothing but negative 1. So you can write sum of roots as negative 1. What is product of roots? Product of roots is alpha into alpha square, that is alpha cubed. What is alpha cubed? We already know that it is equal to 1. So I've got sum of roots and product of roots very easily. I can say that x square minus sx plus p equal to 0 will be the required quadratic, which is x square plus x plus 1 in this case, right? Because this negative sign here and negative sign here, so it will become plus 1. X square plus x, product is already, we have calculated, it is equal to 1. So x square plus x plus 1 is equal to 0 is the right option. Okay, let's look at the next one. If the roots of quadratic equation ax square plus bx plus c equal to 0 are alpha beta, and roots of this quadratic with coefficients given in capitals are alpha minus k and beta minus k, then this expression here is equal to, see, I've spoken in detail about difference of roots. Difference of roots. What was difference of roots? Difference of roots was equal to root d upon a, right? This is the difference of roots. Okay, we have talked about it in details in our lectures. So why have I mentioned this in this particular question? Because just by noticing the roots of these two equations, I could gather this information that the difference is same, right? Because the difference of these roots will be alpha minus beta or beta minus alpha, and difference of these two roots will also be alpha minus beta or beta minus alpha, because this k will get cancelled once you subtract these, right? So the difference of these roots of these two equations is same. So what I can say is, so root d by a for this one, which is b square minus 4ac square root divided by a, which is a in this case, is equal to difference of roots of this equation, which is b square, capital B square, minus 4 capital A into capital C divided by a, which is also written in capital, right? Now if I square both the sides, I can say b square minus 4ac divided by small a square is equal to b square minus 4ac divided by capital A square. Now see, what kind of expression do I require? I require capital A, B and C in my numerator. So what I can do is I can bring it here and I'll take it there. So my answer will be capital A square by small a square, which is option C, right? So if you know about difference of roots, then you can solve this question directly. Okay. So this was about this first lecture on worksheet number 2. We will continue with the next set of questions in our next video. Okay.